Good morning, good afternoon, or good evening, everyone, from wherever you are joining us from. My name is Jiun Kang, and I work for the Transport Sector Office of ADB. Now, I am overseeing the e-mobility support and investment platform for the Asia and the Pacific region. I'd like to warmly welcome you to today's webinar, Opportunities for Second Life Batteries and Energy Storage Systems in DMCs by Dr. Tack Kim from Korea. This webinar is organized under the e-mobility support and investment platform for the Asia and the Pacific, which aims to build up the capability and support the scaling of e-mobility financing. The platform is operated by ADB in collaboration with UNEP and co-financed by ADB and the Global Environment Facility, GEF. Last week, we had an interesting panel discussion on the sustainable end-of-life management of EV batteries, where the focus was on battery recycling, but we also touched upon the second life of batteries. Today's session is a continuation of this discussion, as we will be deep dive into the repurposing and reuse of EV batteries. If you'd like to join the e-mobility community under the platform in order to stay up to date on the platform's activities, please fill in the assessment survey where you can leave us your contact details in case you have not done so already. The QR code to the survey is now available on the screen, and we will share a link to the survey in the chat as well. As part of this webinar series under the e-mobility platform, we arrange this type of webinar every 2 weeks, and you can see the upcoming webinars now on the screen. I'll be actually speaking in our next webinar on April 24th, discussing the necessary conditions for an effective second-hand EV market, considering both policy and industry aspects. We will share the registration link to that webinar in the chat as well. Mosh Mahmood from our implementing partner, Integrated Transport Planning, will be moderating today's session. So let me hand over to Moshi to guide us through the rest of the webinar session. Mosh, to you.
Thank you, Jim. Good afternoon, good morning to everyone, wherever you are. Before we introduce our today's speaker, just a couple of house rules. In order to run this webinar session smoothly, all the microphones are disabled. At the end of today's session, there will be some time for Q&A question session. Please send your questions through the Q&A function available at the bottom of the screen. You can send questions throughout the presentation. We will take those questions at the end of the presentation during the Q&A session. In comparison to our webinar series last year, we have also extended the slot from 30 minutes to 45 minutes to ensure we have sufficient time for discussion. Please note that this webinar session is being recorded and it will be shared with you after the session. Now, let me introduce our speaker today, Dr. Tack Kim. Dr. Kim has dedicated almost a decade to researching and advancing business strategies for battery remanufacturing, reuse, and recycling in the electric vehicle industry. He has established a battery reuse center in Korea and represented the Korea Battery R&D Association over last 10 years. Additionally, he has provided consulting expertise to the World Bank on electric vehicle sector growth. So without further ado, let me hand it over to Dr. Kim for his presentation. As mentioned earlier, you'll have a Q&A session at the end, and please do share your questions using the Q&A function in the bottom of the screen. So Dr. Kim, the floor is yours. Thank you.
Thank you, Moshi. Good afternoon. My name is Tack Kim. I'm working in the Dongsin University right now. I'm the adjunct professor. So today my topic is EV battery second life. So you can see the two buildings. In Korea, we already operation to Second Life battery testing evaluation center in Jeju Island. The second photograph is Naju. So in Korea, we were installed the infrastructure in 2017 and 2012 one for EV battery Second Life. So today I tell you about and our experience how the Second Life battery operation looks like to the republication, reuse, recycling. If this is the use case about Second Life battery. Basically, the EV battery can be used until 65% of the initial capacitance or 70%. So the temper in initial capacitance degradation until to 8% it can be used for more life cycle. But we are expected this battery performance is only remained in the energy performance. Basically, the battery has two characteristic performance like the power and energy. So in that case, below the 8% of the initial capacitance, the power capability is very low, but energy capability still remains. So after that, it can be used another application like energy storage system. This is a EV battery's life cycle. So initially, the battery capacity go down to until 8%. At the times we can evaluation the EV battery performance is the EOL, the end of lifetime. After that, the battery energy performance still remains until 65%. But usually the car owners or car operators, they need much more power performance like the zero backs. So at the times, the EV battery cannot operation is zero back or very low performance about the zero back. So these batteries go to the other application like energy density performance device like the energy storage system, e-mobility, U-shapes, and power bank and lighting. After that, it can go through the recycling. The first of all, the price of the EV battery is much more cheaper than other applications. Right now, I believe less than 180 US dollar per kilowatt hour price is the EV batteries. But other application batteries much more expensive compared with the EV batteries. For example, energy storage system, it around more than 350 kilowatt US dollar per kilowatt hours, and power bank it will be around 700 US dollar per kilowatt hour. So how we can evaluation the EOL batteries? The initial price is US dollar 800 over than 800 118 US dollar per kilowatt hours, but the capacitance less than 8%. We believe it will be around 15 or 17 less than 100 US dollar per kilowatt hour. So you can expectation for the other application price is much more expensive. So we believe the battery can be used on the application like energy performance device like below. Who used to whole life cycle about to the EV battery? We expected the first application is EV, the second life is storage system. After that, it can reuse the precious materials, like to the lithium and cobalt and nickel. For this use case, we can use the more cheaper battery, like the 30 or 50% cheaper battery can be used in energy storage system to write E-shifts. And also the recycling, we can solve the problem in the heavy metal. So this Second Life battery use business model or use case will be more environmental friendly policy or strategies. For this Second Life application or demonstration will be was operated by to the OEMs. So most of the world using Second Life for the steel ride and power storage system and some kind of the backup powers. For this demonstration operated by from the OEM. Actually, the OEM, they doing to the some test driver cars. After that, they will get the more than 100 test drive cars, and then they use the Second Life battery after finish the testing. So before the operation, the EV cars, the OEMs, they get their much more Second Life battery samples, and then they can use the other application like the energy storage system and other things. In case of Korea, we do that demonstration. So we have the first, our challenge is the storage system using the testing battery for the Ionic 5. So in 2017, we make the storage system using Second Life battery around the 250 kilowatt hours batteries, and then it can be operation is similar with the new batteries. Another challenge is like this one. So we do that to hybrid system, like to the new battery with Second Life batteries. This battery came from the e-burst. So we do that some technology, how we can integration new battery and Second Life batteries. Recently, we do that also to the small EV charging energy storage system. So you can see the very small battery packs we stored, we stocking to the small EV pack in small containers, and then it can connection with to the energy EV chargers. For this experience, we can classification for the Second Life battery application. So usually the EV car capacitance with capacitance is around 225 kilowatt hour to the less than 100 kilowatt hours. We can separating to the module levels it around 1 or 2 kilowatt hours. Also the operation voltage is around the 48 volt. So we can separation two things of the application, like the small module level application, like the golf cart and electric wheelchairs, e-scooters, and personal mobility. It will be much more easy and much more cheap safety. And then we just use for the energy storage system using just the pack levels. It doesn't need any to disassembly and the testing and packs and module level. So in our experience, the initial business model is energy storage system just using to the pack levels. After that, we can disassemble the packs. That we can get a lot of the modules, more than one pack have the 10 modules. Then it can be used for the other mobility, like the go-kart and wheelchairs. Now, this is our test recording and our experience to how we can classify the battery pack, and then how we can use the Second Life So you can see the two main source. The first one is the energy and EV cars, and second source is the energy storage system. Yes, people mentioned about the energy storage system only for the have to the energy capability, but in some case, like the frequency regulation, energy storage system, they already have some capability, high performance capability in uh, high rate. So it looks like to the EV battery. So those two kind of the source of the EV battery packs can be used second life. The battery capacitance over than 80%, it will be possible to the reuse. After then, we can evaluation the pack modules and BMS, and then also we testing the performance, and then with the safety performance. After that, the packs will go through the ESS, eParts, and EV cars. Another range is to the less than 8% and over the 65% capacitors will go to the republications. After that, we can, and also similar procedures, process like the testing, evaluation, and assemble the new BMS. After that, it can use for the energy storage system, smaller size, and then UPS and writing. Less than 65% of the capacitance will go to the recycling. So we can uh, uh, extraction to the lithium and cobalt and nickel. This is our full process. So the EV pack go out from the EV cars, and then we can register the performance and various kind of the initial data. That data including to the manufacturing data and system data and pack operation data and life cycle everything. After then, we can testing the packs, inspection and testing. So there are 5 performance testing like OCB, isolate resistance, and capacitance, H and DC resistance, and also we can evaluation the self-discharge. After that, the graded battery packs can be used for the reuse, republication, and recycling. This is our whole process. So in our institution, the EOL battery came to our institution. We can washing and some cleansing in outside, and also we are testing to the electrical safety, and then also testing to separation to the module level, and go through to the testing procedures like to charging and discharging and OCB and a kind of the inspection in outside and inside. After that, we can store the warehouse. This is our challenge to reduce the testing times. Normally, it doesn't have any international standard. So, in our experience, we are just testing for the EOL battery pack, same as to the EV packs. So it needs to more than 12 hours. So for our experience, we are doing to some more challenging to reduce the testing times. This is a common procedure about the full charging and discharging method. So we are charging 3 hours and standby 1 hour, 30 minutes. After that, we can discharging in 3 hours. So it needs to more than 8 hours to operation only. There are a lot of the subside work, but it doesn't calculation in the procedures. So yeah, we do that some challenging in the partial charging and discharging. Actually, the EV battery pack is operation in around the 70 or 60 SOC level. So we do that charging SOC 6% and discharging in the 50%. So we are repeatedly testing for 3 times can be increase the accuracy about the capacitance and performance. For this experience, we do test some demonstration energy storage system using the second life batteries. So for this second life battery, we do test some designing and installation and analyzing, and also we preparing to the firefighting. So this is around the 2 megawatt hour storage system combined with the solar PV and the power supplying for the grid. For this demonstration, we do try the various kind of the cell types, like the cylindrical types, plasmatics, and pouches. So we pour our 2 megawatt energy storage system. We classification 1 megawatt system from the pouch cell because the pouch cell is much more easy to disassemble, and it will be very clear to make the module or pack level. But cylindrical types and plasmatic types very much more difficult to disassemble and testing and combine with the BMS. So we do make some configuration and more detailed design to the cylindrical types and plasmatic types and pouch cells. So we made some module level, and we do that performance testing, and then we finalizing to the storage system racks, and then it can be integrated with the solar PVs. For our expectation or our analysis to the economical assessment to second life, you can see the current EV cars that go through to the recycling. So we can get the cobalt and nickel and some precious metal and also include to the lithiums. But people using to the second life using energy storage system, it can be using or operation more than 5 or 10 years. It depends on to the applications. In 2020, we do that some economical assessment calculation for how is the benefit to use a second life. For this second life battery price, is evaluation around the $250 per kilowatt hours. It is around the 50% of the battery cost compared with the new batteries. So at the times you can much more benefit around $91 million for using the second life batteries. After the second life battery goes to the recycling, and also we can get the same materials like the cobalt, nickel, and lithiums. This is our experience about the circular economic environmental operation condition, like to second life testing infrastructures, and it will be operation to republication and read. So finally, the cell goes through to the centers. After that, we can evaluation the packs and module levels. It goes to the recycling centers. So in this Jeonnam province, we have 2 institution infrastructure like the second life and recycling. So the EOL battery came to the infrastructure institution, and then we can supplying for the second life battery to industrial side. So finally, we can collection to the EOL battery again, and then we using to the recycling. The recycled materials go through the cell manufacturer in the our province or other province. So we believe this the provincial infrastructure will be supporting to the previous government policy about the circular economics. Also, we do that some challenge in life cycle assessment or battery passport. The life cycle assessment will be need to more clear how the second life battery will be benefit compared with the new batteries. Also, we know that to the new battery, they producing the carbon dioxide during the battery manufacturing. But the second life battery, it doesn't make any other carbon dioxide generation compared with to the new batteries. So the second life battery has much more benefit with the environmental issues, environmental regulation or mandatories. So for this business model, for this challenging, we do that some database, how the battery came from the manufacturers and customers, how we can manage to the waste. After that, how the manufacturers or recycler can generation second life battery or precious material during the process. So in this ICA and battery passport will be the most important to monitoring to the battery life cycle and operation and EOL. In my experience, the industrial goes through to the EOL battery came from the IT device. But right now, the EV battery process is much more waste generation. So you guys know a lot of the recycling raw material came from the EV battery manufacturing process. After that, recently the EV battery, recall battery goes through the recycling. After 5 or 10 years later, the second life battery will be generated from the customer side. So I believe to the EV battery recycling is a final goal to the second life. This is my presentation. Thank you so much.
Thank you, Mr. Kim. It's been a really interesting presentation. We do have one question from, we're going to open the Q&A session now. If you have any other question, please, by all means, post that on the Q&A box. But we'll start with our first question from Mr. Suji Kimura. For the transport use, I believe weight capacity ratio is important since battery is dead weight. Is it popular to use second use battery to two-wheelers and e-ships?
Yes, yes, it's very important. So, in the pack rebels, the weight around more than 300 or 500 kilograms, and after that, after your battery goes through the disassemble until to the module levels, and then the module level is very right weight compared with the pack levels. So recently the two wheels and E-shifts much more convenient to use the module levels, not the pack level. So the module level is much more cheap because the outside of the case or other safety pack is not included in the module level. Yeah.
Okay, thank you. Then I do have one question. Now, given the way EVs or the adoption of EVs accelerating in Asia, at some point we'll have a lot of batteries to handle, right? I mean, the market is getting saturated. Are we ready for this, particularly in Asia?
Yes, I believe. Yeah, right now, I believe to the much more big market in the China and European and US. But we can see a lot of the information from the Asian countries. Indonesia, and India, and other countries. So people want to, but I believe to the we agree to the COP21. So all of the countries doing to the some carbon neutralization in 2050. For these goals, the first potential powerful approach is to use the EV cars. Actually, there are a lot of the carbon dioxide generation from the transportation side and industrial side. So I believe to the EV car is to the good solution to reduction of carbon dioxide generation. And also, so I believe to the all country will be have to the cell manufacturer and EV car manufacturers and other supply chains, because the battery will be spread out to the not only to the EV cars, the energy storage system, solar lighting, e-wheels, and some other much more devices. Yeah.
So it means, yeah, we have large enough market to
Yes.
absorb those second use batteries.
Yeah.
Okay. There is another question from June Kang. In terms of recycling the battery, how do you think NCM versus LFP in short?
Yes. Yeah, there are some not enough information about the iron phosphate batteries. Yes, iron phosphate battery is not enough performance in the energy compared with the NCM, and other high performance batteries. So we believe the iron phosphate battery is very limited to use the second life. Also, very limited in the recycling. There are not enough the economical benefit in right now. Yeah.
Then, yeah, another question is Mr. Suji Kimura. It is explained that inspections or tests will be conducted for reuse. I guess the condition or quality of second-use batteries varies a lot. Is there any standard way to evaluate condition of batteries in relation to the fire accidents reported in the news, mobile batteries or EV batteries? The firing in the mass facility may cause a big incident. Absolutely.
Yes. Yeah, this is a big headache. So yes, in IEC TC21 SC21A working group 6, preparing to the second life battery testing method, but it is only for the mobile device, not the EV batteries. And also in Korea, in China, also have to this testing evaluation standard. This is only for the Chinese government, not only for the China national standard. Korea also have to the association standard also have, but there are no international standard, because the new battery is it's more clear to testing evaluation by the international standard. But second life battery is not it is more variety performance and variety diversity with new batteries. So it would be very hard. So we believe the manufacturer or pack manufacturer have to responsibility how they can guarantee the second life application or second life batteries. So sometimes if the cell manufacturer or second life battery application manufacturer is separate or different, they will be need some more certification authority or some institution. Yeah. But I believe it will be solved in near futures. Yeah.
All right, thank you. Can I request all audience, in case if you have any question, please can you spell the full abbreviation of if you use any acronym, please send a full abbreviation of it. I have one question to ask Mr. Kim. This battery industry, like the recycling facilities, this can be quite an expensive and complex facility.
Yeah, yes, it's sometimes it's very cheap and sometimes it's very expensive. And depend on we can classification to the two levels in pre-treatment and hydro or pyrometallurgy process. So the pre-treatment is to make the black powder or black mass. It will be not so much expensive or not so much difficult. But the hydrometallurgy or the pyrometallurgy process and infrastructure equipment is expensive, very much for high technology. So, but you know, the recycling cause some environmental problems. So, and US DOE doing to the some researching activity in the direct recycling. So I believe to the current recycling industry or technology should be developing more clear, more environment friendly technology like the direct recycling, because we know a lot of the environmental problem in the recycling facilities in Korea and other countries. So
Okay.
yeah.
Yeah. So thinking about the countries in Asia and especially the Pacific Island countries, does it
Yeah.
make sense to have domestic industry as such for those small island countries, or are there opportunities to create a regional market? Therefore, a
Yes.
major facility in one country where other neighboring countries can benefit from?
Yes, I believe. I actually in this year, last year, I'm joined to the PIC regions to the EV battery evaluation and standardization. I believe to one representative of the island doing to the uh, testing or certificating and evaluation for the cell or pack levels. All the pack or cell doing to the testing, it will be much more safety. So I suggest some kind of the union to battery testing and certification union operating the overseas importing battery testing and evaluation and managing whole life. Then it will be much more safe environmental in the other countries. Yeah.
Thank you so much. I think we are pretty much on time. Unless there is any other question from our audience, I think we can wrap this session for today. So thank you so much, everyone, for taking the time to join us. And special thanks to Dr. Kim for his excellent presentation. It's really informative. Learned a lot from this session. So we will share the recording with all registered participants as soon as possible. And we hope to see you in the next webinar with our colleague, Jiun Kang, talking about EV secondhand market development, a case study from Korea. And until then, and sorry, before I finish, it will be at the same time, 3 p.m. Registration link will be shared with you. So until then, thank you so much and have a good day.
Okay.